Hi everybody, sorry for not being here today, but we'll go ahead and take a look at our notes. Please follow along with me and copy along for your own so that way you can work through your assignment today. We're going to talk about properties of logarithms. Mainly we're going to look at expanding and condensing. This actually should be a pretty quick and easy lesson. There's very little arithmetic. It's a lot of just kind of rewriting. And if you take a look at our meme, kind of gives you a hint. We've got our character that has a little guy on the shoulder, but if he's trapped inside of a logarithm, we can actually move him up into the front. And so what this shows is that we can rearrange logarithms to where we have just one thing in the argument and one thing only. And that's one of the things that we're going to want to try to do. So today you're learning how to use properties of logarithms, and you're going to be able to do that to expand and condense logarithms. This is going to help us out in our next lesson where we try to solve log equations, being able to rearrange them to where it's convenient for us. So let's get started. As a warm-up, let's remind ourselves about exponential expressions. The product property with exponents says if we're multiplying two numbers with the same base, we can just add the exponents. So x to the 6 times x squared means we can add those two exponents, and that can be rewritten as x to the 8th. If we are dividing two numbers with the same base, that means we can subtract the exponents. And so x to the 6 over x squared can leave us with x to the 4th. Then the power to a power property says that if we are raising one product or one power to another power, we can multiply the exponents, and this can give us x to the 12th. This is all stuff that we learned back in Unit 5. Okay? Now we can apply these properties of exponentials to logarithms. Because logs and exponentials are related, we can apply those same properties to logarithms. Okay, and we'll start off with the product property. The product property says that if we have a logarithm with any base and we have a product inside the argument, so x times y, we can actually separate this out into two separate logarithms. They both have to have the same base, and then they each get the respective parts of the product. Okay, but here's where it ties in with what we had before. If we have multiplying two numbers with the same base, we can add the exponents. If we are multiplying two parts of an argument, we can separate that out into two separate parts by using addition. Okay, so let's see how we can expand or condense. Expanding means we start with one logarithm and we go to two, and we can see how that would work here. We want to expand this logarithm. We have one, we want to make it two. We can recognize there is a product inside here, 9 times x. So that means we can separate it out into two separate logarithms, both having the same base. This one we don't see the base there. We remember from last lesson that that's the common log, so it's base 10. We don't need to write it. And since we are multiplying 9 and x, that means we will add the two logarithms. And that's all we're trying to do in this stage, is just rewrite by expanding them out into two separate logs. Okay? Now, if we've got two logarithms, we often want to condense it down into a single logarithm. And if we see that we are adding the two logarithms, that means we want to multiply the two arguments. The only way that we can do that is if the bases are the same. Since the bases are the same, we can do that, write it with the log base 2, and then we multiply the two arguments together. Simplifying that can give us log base 2 of 3 times 5, which is 15. And that is the simplified version. Okay? Continuing on, we have ln. Remember that that's the natural log with base e. Now we have three parts in our argument. A product of three different values, 3, x, and y. Since there are three different parts, that means we should have three different logarithms. The first one will be natural log of 3. The next one will be natural log of x. And then the next one will be natural log of y. We just separate them out, each one getting their own log. And since it's a product, we add through each one. Okay? Our last one is another condensing one. We have log base 5 of x plus log base 5 of 4z. Since it's addition, we can rewrite that as a product. And whenever we are making a product of these, we will generally put them in first with the coefficient and then alphabetical order. So we would say 4xz. Okay? and that's condensing using the product property. Easy enough. The next property we would talk about is the quotient property. Quotient means division, which means we should see a fraction bar. So we may have log of any base b of x divided by y. So if we see a fraction bar, then that means we immediately know we can apply the quotient property. To make an analogy of what we had here, we were doing multiplication, and that turned into addition. Now if we're doing division, that's the inverse of multiplication. So let's do the inverse of addition. That's subtraction. So whenever we see the fraction bar, that means we are going to be subtracting two logarithms. They have to have the same base. And here's the other special note to this. X is in the numerator. This is a positive logarithm. Y is in the denominator. That makes it a negative logarithm. So make sure you add a special little note over here to the side that positive logs go into the numerator and negative logs go into the denominator. Okay? So hopefully that can be easy enough for you. So let's apply the quotient property. As soon as we see a fraction bar, we should know that that means we should have subtraction. We'll have two logs, and we're going to subtract between them. My positive logs are always the ones that are in the numerator, so my first one is positive log, that's log of 4, and then my 3 is in the denominator, that's going to be log 3. And that's it. That's simple. And we don't need to do anything else with this. We could punch this into the calculator, simplify it, but if I'm told to expand, I actually want to see the logarithms. Okay? Now, we have multiple logs. Let's try to write it as one singular log. They're all base 4, so I know I can combine them. And as soon as I see subtraction, that tells me I should have a fraction bar. As soon as I see subtraction, I should have a fraction bar. All of my positive logarithms go into the numerator. So looking at this, which ones are my positive logarithms? X, Y, or Z? I have a positive X. Next, we've got Y and Z. Those are both negative. Any negative logs go in the denominator. Okay? Expanding is going to go in the opposite direction. Okay, we have natural log of 4 divided by 273 times x. As soon as we see the fraction bar, we know we should have some positives and we should have some negatives. So I will start off with first my positive one. That's the one in the numerator. And then I'll have negative ones, 273 and x. Now this is 273 times x. That means that's a product of two different pieces, but since they're both in the denominator, both will be negative. So we still have 3 logarithms here. Any of them that are in the negative, or any of them that are in the denominator will be negative. And that's it. That's all we need to do. Last one, number 2d, has natural log of 2 plus the natural log of x minus the natural log of y. Okay? So when we're working through each of these, we want to condense. Since we have multiple logarithms, I want to condense into a single logarithm. Okay? Condensing into the single logarithm, all of my positive logs go into the numerator. The 2 is positive. The x is positive, so those both go into the numerator, and they're going to multiply with each other. Any of my negatives go into the denominator, and we have it like this. ln of 2x over y. That's it. The last one is what we call the power property. Okay? The power property is a pretty simple one as well. And it says that if we have a log of any base where the argument contains an exponent, we can actually take that exponent and move it to the front to make it a coefficient that just multiplies. So that's a times log base b of x. And again, these properties can go either way. So if we see a coefficient, we can move it to the exponent if it's more convenient for us. If we see an exponent, we can move it to the front if it's more convenient for us. If we are condensing into a single log, we usually want to see the exponent. If we are expanding to several logs, we usually want to move that exponent out so that only the variable or single number is left over in the argument. So let's see how this one works. We've got log of x squared. I see an exponent of 2. I immediately recognize that exponents can always move to the front, and they are going to multiply with the logarithm. So that's 2 log of x. That's it. It's that simple. Okay? The next one, we've got negative 2 times log base 6 of 3. So this is a single log. I could leave it like this, but I want to try to rewrite it in an equivalent way. And I recognize this coefficient. I can move it up here. And why I see that is because since I've got a number here, maybe I want to actually try to simplify that. So it'll be log base 6 of 3 to the negative 2 power. And we want to remember some of the properties about exponents. When we have a negative exponent, that means a reciprocal. The reciprocal of 3 is 1 over 3. Now we still have to square it, so just square each part. 1 squared is 1. 3 squared is 9. And that's the argument of our logarithm. Log base 6 of 1 over 9. And that's as simplified as that logarithm can go. Okay? Now sometimes we are going to combine these different log rules. In example 3c, I see that I have 3x to the 4th. This is my argument. Now ask yourself, what is getting that exponent of 4? Is it the 3 or the x? Well, since the 4 is inside the parentheses that I just made, it's only the thing immediately to the left that's getting that exponent of 4. So it's just the x, which means this is log base 5 of 3 times x to the 4th. But the 3 is not receiving that exponent of 4. So the first thing I might want to do is separate this out into 2 separate logarithms using the product property. Since it's multiplying, I'm going to add those. And we have log base 5 of x to the 4th. Now, once I've got that, I can take this 4, move it to the front, and I have this log base 5 of 3 plus 4 times log base 5 of x. Okay? And that is as simplified as we can make it. The last one, we have fraction exponents. Now, fraction exponents are going to be special cases, or fraction coefficients are going to be some special cases that we want to remind ourselves about. So let's first recognize what's happening here. I have 3 different logarithms, all with base e because they're natural log. And each one, or we see a subtraction, so that tells me I should have a fraction bar. Okay? All of my positive logarithms are going to go into the numerator. My negative logarithms are going to go into the denominator. And then I have these coefficients. The coefficients can move to the exponent. Now, only the x and y have that coefficient, and they each have that coefficient of 1/2. So each of them have an exponent of 1/2. Now, any rational exponent like this, x to the 1/2 power, remember we can write those as radical expressions, and we often will want to do that. So an equivalent way of writing x to the 1/2 power is to say my index is the denominator, so that's 2. Now we don't need to write index 2. And then the exponent of x in my radicand is 1, but we don't need to write it like, we don't need to write that 1. So I can write x to the 1/2 power as the square root of x. And since both of those are receiving that 1/2 power, then we can write it both inside the square root. Now, since the 2 in the denominator does not have that 1/2 exponent, it does not get included in the square root symbol. Okay, so take a look back through these, review any that you need to, but here's your basic summary of what we did. Okay? The product property says that if we multiply 2 numbers with the same base, then we can separate them out by adding 2 logarithms. If we are dividing 2 numbers in the product, then we can separate them out with logarithms of the same base, but we subtract. Any positive logs go in the numerator, and any negative logs go in the denominator. Finally, we have the power property. Power property says that if your argument has an exponent, then you can actually rewrite that by moving the exponent down to the front, make it a coefficient, and multiply. So the extra note we can add to this is that exponents can move to coefficients. Now, there are extra examples on the back page that I will go through and have posted onto Canvas for you. Okay, I invite you to try to do those examples or work through them, try to follow along with them, and use that to work through your assignment. So please take a look at these, work through diligently, and if you need to continue working through your investment project, then you can go ahead and do that as well. But this should give you a jump on a start on your assignment. Make sure you finish the notes by looking through and completing the examples that are on the back of this page, all through here. Okay, and then get to work on your assignment. Thank you guys for watching. Have a great day.